Alrighty, here we go. This is a lesson about slope and rate of change. Now, slope you probably remember from Algebra 1 as rise over run, the change in x over the change in y. The formula you remember is y2 minus y1 over x2 minus x1, which is all still good. So remember, a couple things. Positive slope. Positive slope goes up as you read from left to right. A negative slope goes down as you read from left to right. A slope of 0 is a horizontal line. It's neither rising or falling. And undefined is a vertical line because there is no change in x. So a couple little notes. The bigger the slope, the steeper it is. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slope. Okay? Perpendicular have opposite reciprocal slope. So, this is what we're going to do. We're going to start out with a couple examples, and I'm going to show you one other way that you can find slope. Okay? So, question number 1. I'm going to show you another way that rather than your y2 minus y1 over x2 minus x1. If you stack the 2 points on top of each other, doesn't matter which order, so we're just going to move the -3, 5 underneath here. What you do is you figure out how far of a jump it is from one to the next. So how far do you have to jump to get from 1 to 5? You have to add 4. How do you get from 2 to a -3? You have to subtract 5. Okay, so then what you do is you take your change in y over the change in x, and then you would just write it as slope. So your slope would be a positive 4 over -5, which would be -4/5. So that's another way you can do it. It's, call it the jump rule or whatever you want to call it. Number 2, this will do the old-fashioned way. For the second example, we're just going to use our formula. So remember, this is x1 and y1, this is x2 and y2. And what you do is you just subtract using the slope formula written at the top. y2 minus y1. So y2 is 3 minus y1 of 2 over x2 minus x1. x2 is 14 minus x1 of 4. And you just subtract and you get 1 over 10, and that is your slope. So the slope of number 2 is 1 over 10. Finally, number 3. This one is same thing. Go ahead and use either formula that you like. It doesn't matter which order. You don't have to have the bigger one come first. For example, if we have 1 minus 4 over 8 minus 8, we're going to end up with a -3 over 0. Now here's a quick question. Can you divide by 0? Of course you can. So whenever you have 0 in the denominator, your slope is undefined. Okay, it is undefined. Alrighty. So here we go. Let's talk about a couple more things. Let's talk about parallel and perpendicular lines. So remember, lines are parallel if they have the same slope. Lines are perpendicular if they have opposite reciprocal slopes. Not just opposite and not just reciprocal. They have to be opposite and reciprocal. Okay, so we're gonna do an example really quick. That goes with the examples right above. So number 1, we found the slope was -4/5. What slope is parallel to -4/5, and which slope is perpendicular to -4/5? So the answer, parallel, -4/5, because they have the exact same slope. And perpendicular is a positive 5/4. We have to take the opposite and the reciprocal. And that's how you get perpendicular. So why don't you take a second and try number 2. Go ahead and pause the video. And here we go. So the slope that we got for number 2 is 1 over 10. What's parallel to 1 over 10? 1 over 10. What is perpendicular to 1 over 10? -10 over 1, or just -10. Now there's a little question between 1 and 2. Which one is steeper? So when we ask which one is steeper, which one has a bigger slope, we ignore the negative, okay? So this one is actually steeper because you're going down 4 units for every 5 units that you run, when in the second example, you only go down 1 unit for every 10 units. So, I mean, if you think about it as like a hill, think of it like a ski slope. You're going to be going down this one pretty quickly, when this one, it's just a nice little gradual 1 over 10. Okay? Finally, the third one. You got to think about this for a second. What would your reciprocal of undefined be? So if we know that the slope is undefined, meaning it is a vertical line, our parallel obviously has to be the same, undefined. What is perpendicular to a what is perpendicular to a vertical line? A horizontal line. So that means it is 0. Now we can go all the way back up here, because I'm sure you're wondering, how did you get a 0 for a reciprocal of undefined? Go back to this. What's the reciprocal of 3 over 0? 0 over 3. And when 0's on top, your answer is just 0, because 0 divided by anything is 0. Number 4 and number 5 are going to go with slope as well. What we're going to do, though, is we're just going to look at number 4 and figure out what the slope is just by looking at a graph. We're going to count. So remember, slope is rise over run, and we read left to right. So if we start with the blue line, here's our first location that we're starting, because it's the furthest point to the left, and we count how far did it go up and to the right for this second dot. So we went up 1, 2, 3, 4, 5, and we ran 1, 2 to the right. Since we went up, our slope is positive 5 over a run of 2. All right. The red line, line 2, is a horizontal line. Horizontal lines have a slope of 0. And the green line, as you can see, as we read from left to right, it is going down. So if we were to start here and count, we go down 1, 2, 3, and we go over 1, 2, 3, 4, 5. So we have a slope of negative 3/5. Question number 5. It's a word problem that deals with rate of change, and rate of change is basically slope. So you're driving in Italy, and you are 420 kilometers from Rome at 9 a.m. At 3 p.m. you are 108 kilometers from Rome. What is your average speed? So notice the key is with the AM and the PM. You don't just subtract like you would normally do it in a regular slope problem given 2 coordinates. So the first thing you want to do is, come up with where you're starting. So let's say what's your average speed. We can call 9 a.m. our 0 hour, because that's when you're starting. And then we can say at 3 p.m., that is 6 hours later. So that'll help us write some XY coordinates. So we can say at 0 amount of time, we're 420 kilometers away. And then at 6 hours later, which is 3 p.m., we are only 108 kilometers away. So here's another example where you can just use the jump rule. This is down by 312. This is going up, obviously, by 6 hours. So we have negative 312 divided by 6 hours, which means we have 52 kilometers per hour. That is our rate of change. Okay? Number 6 and number 7, we're going to apply some of the rules that we just learned. So number 6, all it's asking is, are lines 1 and 2 parallel, perpendicular, or neither? So what you're going to have to do is you're going to have to find the slope of both lines. So the slope of line 1, you can use whatever formula you want to use. The jump rule, you could use your good old-fashioned y2 minus y1. The slope of line 1, you should find is negative 4/5. The slope of line 2, you should find is 5/4. So then all you have to do is analyze those two. You see that they are opposite. One of them's positive, one of them's negative. You also see they're reciprocals of one another. So that means these two lines are perpendicular. So that's all you have to do. If they were the exact same slope, you'd call them parallel. If they were neither, you would just call them neither. All right, number 7. Tricky problem. what you have to do is you have to find k using the slope formula. So first thing you might want to do to help keep this organized is call this x1 and y1 and this x2 and y2. So then use your slope formula. The slope formula is y2 minus y1. So for minus, careful, this is k minus 10. Since there's two parts to it, you want to put it in parentheses. Over x2, which is 2k plus 2, minus x1, which is 2. And now let's simplify a little bit. Okay, let's simplify this. So we could rearrange the top. We're going to distribute the negative, and we're going to get negative k. And we're going to make that distribute negative 10. It turns into a positive 10. With the 4 is 14. Over 2k plus 2 minus 2, we can just call 2k. After we simplified our slope, we can set that equal to the given slope of 2/3. Now all we have to do is solve for k. How do you do that? Good old-fashioned cross multiplying. So we cross multiply 3 with the negative k plus 14. That's going to give us a negative 3k plus 42. And we're going to set that equal to, we're going to cross multiply with our other 2k times 2 is 4k, not 4x. And then all you have to do is solve. So we add the 3k to the other side. We're going to get 42 is equal to 7k, which means k is equal to 6. Okay, so that's a little bit of a tricky problem. Just remember, you have to simplify your slope formula using the 2 points with the k's, and then after you simplify it, you set it equal to the given slope of 2/3, cross multiply and solve, just some algebra. Alrighty, and finally, number 8. It's another application type problem. Why don't you pause the video and try this one on your own. Okay, so this is similar to the driving in Italy problem. Let's see if you were able to handle this. Basically, the first thing you want to do is at 1 p.m. we can call that our 0 hour. Okay, 1 p.m. we can call our 0 hour because that's when we're starting, and we find out that it is 81 degrees. And then at 6 a.m. you should have calculated that as 17 hours later. Okay, so the 6 p.m. is 17 hours, or 6 a.m. is 17 hours later, and the temperature is 47 degrees. So if you take your jumps, it took 17 hours for the temperature to drop by 34 degrees. So you find your slope, negative 34 over 17 has a slope of negative 2. The slope, negative 2, is known as your rate of change. So negative 2 degrees per hour. Okay, so now what we're going to do is we're going to use that to figure out what the temperature was at 9 p.m. So we're assuming that at 1 p.m. that was the hottest point of the day, and it just kept on decreasing from there. So we're going to predict what it was. Well, think about it. 9 p.m. is how many hours after 1 p.m.? Okay, that is 8 hours later. So all you have to do is take your rate of change, which is negative 2 degrees per hour of 8 hours, and the temperature drops 16 degrees. Now that's not answering the question. It says, what is the temperature at 9 p.m.? So it started at 81 degrees. You have to subtract 16 degrees, and it is 65 degrees at 9 p.m. And that concludes our lesson. If you have any questions, you know where to find me.